Alex, if you want to sort of get caught up on what you missed, you'll probably get a lot caught up just what we do today. But I'm going to make sure I record tomorrow morning and put it up. You'll just have to look in the folder that says 1B instead of the 1A folder. And actually, you know what? It'll be so on Google Classroom. What I'm doing on Google Classroom is I've decided I'm just making one each week. I'm going to make one folder that says YouTube live streams, and then they'll just be by date. So for this week, you'll see 2.8, 2.9, 2.10, 2.11, and 2.8 and 2.10 are going to be exactly the same, but it'll just be your class versus, well, yeah, they're technically your class, but there'll be A group versus B group, but we're going to do the same stuff. So if you're ever trying to go back and look, you'll see 4 videos in there, and so you'll be like, wait, we only had 2 classes. Oh yeah, 2 and 2. So, but they'll be duplicates of the same material. It'll just be a little bit different. My jokes will be different. If you watch both of them, then you'll see when I like lamely try to do the same joke the second time because it worked well the first time, and then it like falls totally flat. And done that. Have you guys ever done that where you told somebody a joke and it went over really well, so then you tried to tell it to somebody else, and then they're just like, "What? That's a stupid joke." Oh, darn it! It was so awesome the first time. Okay, I gave everybody one of these. Did I? You got one? Did I give you one? Guys, I'm as I said day one, I'm gonna be trying stuff and then like maybe changing it if I think it's simpler and just trying to make it work better. Well, here's what wasn't working for me. I was putting in an assignment for you guys, and then I was putting in another assignment for you guys, and then another assignment for you guys, and then a Friday assignment for you guys. And then I had to put this one in as a different assignment for these guys, and then a different assignment for these guys. But they were the same assignment, but then I was having to go in and click on, okay, who's supposed to see this assignment? And I don't know if you guys noticed, but you all were seeing these assignments yesterday because I forgot to like check off the students who were supposed to see. It was a nightmare of trying to keep track of things. And then I would go to grade and there's all these assignments and it's, but they're all the same assignment. So here's what I'm going to do instead. I'm going to give you one of those every Monday. If you look at that sheet, you'll see that it says on Monday, this is what you're going to do. And the answer is come to class. There's nothing to do right now. There's nothing to turn in. Starting next week, I'm probably going to have a small homework assignment. It'll be like practice problems on Mondays. On Tuesday, but if you're absent, you watch the live stream video if you can. The live streams apparently don't show up on the Chromebooks, but you can watch them from your phone or your home computer. We're still trying to figure out why on the Chromebooks. You take notes and you fill out the Ralph thing, the form. That's what you do if you're absent. On Tuesday, if you're absent, it's the same thing. You know, watch the live stream, take notes. And I say take notes intentionally because just like in class, if you're watching the lecture, you can pause it and write stuff down. I'd say it's even easier to take notes when you're watching the live stream. Harder to focus because it's just like this video playing, but easier to take notes. But then it says classwork. And so then that's, you know, what we're going to do on Tuesday. So like today, we're going to do classwork. So I've got a little worksheet of practice on these things. Wednesday, it says do this assignment and then do the remote attendance learning form. Thursday, it says to do this assignment. Friday, it says do this assignment. And Friday assignments, they may be changing the Friday thing. I don't know what it's going to look like. I don't know if I told you this yesterday. But they're talking about us having to have like these little 15-minute Zoom meetings with all our classes on Friday morning. Why? No reason at all. And so we're arguing with them. The staff is like, that's stupid. We don't want to do that. What we want to do is teach them stuff. And so how can we best do that? And we're trying to figure that out. But the reason I want to do this is because it makes my life much, much easier when it comes to putting the assignments in. Because now all you have to do, good morning, all you have to do is look through this thing and you'll know exactly what you need to do. And I'll give you one every Monday morning. And I'm going to try to remember to post it up in Google Classroom too. So if you can't find it because it's a piece of paper, you can go to Google Classroom and you can find the Group A weekly thing. I'll give you another one next Monday. It'll say, now this week, do these things. I'm going to try it. And hopefully it works. If you run into any confusions, guys, please ask me. Like I had people not do the from the other group not do stuff yesterday because I forgot to put it on Google Classroom because I have to put it up twice. But they didn't just send me a message and say, Mr. Harmony, where's the assignment? Even though they knew there was going to be an assignment, they just wrote nothing and they didn't do it. It's like, and then I had some people like go do the classwork because they didn't see a Monday assignment, so they just went and did the classwork, which they're not going to do till Thursday, which they don't know how to do because we haven't talked about it yet. So send me messages. If you see a problem, just, Mr. Harmony, what assignment are we supposed to do? I'm so confused. I don't see anything there. Oh, I forgot to put it up. And I'll get it up immediately, and I'll respond to you immediately, and we'll get it resolved, all right? But there you go. Hopefully that helps. Hopefully that makes the process easier. And hopefully we'll settle into a groove. And right about the time we settle into a groove, what will they do? Change everything. Exactly. So, okay. Guys, yesterday we were talking about completing the square. You still got your algebra tiles out there. You don't need to get them out right now because we've already done this one. But here's what this looked like. We said, let's take the squared term and the x term, and let's build a square out of it. You don't have algebra tiles, and you'll need them eventually. I'll dig them out for you in a minute. And so what we did is we said, well, this is a square. And if I was going to make a big square, since I got 8 of these, I'm going to put 4 of them on each side, which means that our side lengths are x plus 4 by x plus 4. But it wasn't really a square because there was this big hole right here. And we said, well, we're going to have to put 16 of the little ones in there. And when we put 16 little ones in there, now we've actually got a square. But we added 16 little ones that we didn't have to our tile. So we put 16 negative ones next to it to balance it out. Notice that these right here are 0, and that's x squared plus 8x plus 10. That makes sense to everybody? Are we cool with that? So the idea of complete the square is what we're saying is we completed the square by putting those 16 tiles in there, but we kept the equation in balance by also subtracting. Now, why would we add or subtract, or add and subtract? Because we want there to be a square. Why do we want there to be a square? Well, let's look at that square. It is x plus 4 by x plus 4. So the area of this square right here is x plus 4 squared, agreed? Length times height, area of a rectangle, or a square. So that square is x plus 4 squared. That's the stuff in pink. And out here, I've got my negative 16 plus 10, which is minus 6. Hey, where's the vertex of this parabola? Anybody? Negative 4, negative 6. Because remember yesterday when we were factoring them, and then we were finding the x-intercepts, and then we were averaging the x-intercepts, and that gave us the x value. and then we would take the x value and we would plug it back into the equation, and that would give us the y value. And then finally, after 20 minutes of working, we knew where the vertex was. Or we take these and we make a square. To make the square, we added 16 to keep it in balance. We subtracted 16, and then we rewrote it like this and said, oh my gosh, the vertex is at -4, -6. A much, much shorter process. Travis?
Why is it -4?
Remember, this is x minus h. The question is, what value of 0? And the value that makes it equal to 0 is -4. The x value is always going to be the opposite. Remember, our standard form of the equation is x minus h squared plus k. And so to make that positive, I had to put a -4 in there. That make sense? Yeah, that's the tricky one to remember. That's always the hard one to remember. This one's easy. Plus makes it go up, minus makes it go down. This one you sort of got to remember, oh wait, I'm trying to make it equal to 0. And so it's the opposite. So let's do another example, and then I will have you guys do one. So we'll do this one together. My second example is, hang on a second, got to turn to the correct page. Where'd my second example go? Let's do this one because we factored this one yesterday. I'm going to leave that one on the board and just do another one over here. Y equals x squared minus 10x plus 16. Wait, did we factor that one yet? Yes, we did. Because this was, remember, -8 minus 2. So we already know that the x-intercepts were at 2 and 8. And we figured out that the vertex had to be at 6, if I remember correctly, and blah, 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 blah. So we already know the answer. We can flip back in our notebooks and find it. So let's complete the square on this one. We'll do this together. We're going to draw the algebra tiles. In fact, let's do this. Why don't you guys get out an x squared and 10x tiles out of your bins. We get out an x squared tile and 10x tiles. Where are they? That'll work. There you go. You betcha. So an x squared tile, it's a square, it's blue. The x tiles are little rectangles. They're also blue. They're the light blue color. Yeah, that one. That's the x squared. This is a y squared, but we're not using that one. Now, when we make our square this time, remember that we need to flip the x tiles over because I have negative 10x. And so the x tiles need to be red side up. And yet, you only need one of those. So red side up on the x tiles, blue side up on the x squared tile. I'm going to say you won't need the ones because we probably aren't going to have enough of them anyway, and so we're gonna visualize all the one tiles today. Guys, go ahead and make the square with the x squared and the x tiles, but I don't think, because you're going to need a lot of ones, and I don't think there's going to be enough of them. So we'll visualize them for this second round. All right, so here we go. I'm going to draw my x squared tile. There it is. It is x by x. And the question is, how many on each side? Alex, can you, this is your first shot. Do you want to take a shot at this? 5. Yeah, good, good. I was like, well, I don't want to put you on the spot. You missed yesterday, but you got it. 5 on each side, but they're negatives. So I'm going to make them red. 1, 2, 3, 4, and 5. That's minus 5 along the top there. And 1, 2, 3, 4, 5. Minus 5 down the side here. Guys, as we move through this, keep in mind that the goal is to not have to draw the tiles every time, because it's time consuming, it's boring. If you can get the visualization in your head, it becomes a much easier problem. So just keep that in mind as we go forward. Start to, as you're building these every time, start to be visualizing, hey, I'm seeing these patterns. And so I don't have to draw them every single time. Now, can you draw them every single time? You betcha. Or if you get stuck on a problem, yeah, draw them. Go for it. Nothing wrong with that. So the next question is, what do I need to fill this in? How many do I need to fill in that square? And are they going to be positive or negative? So give that a second of thought. How many is the first question? Positive or negative is the second question. I'll let you think about that for just a second. Rhiannon, how many do you think?
25.
You guys agree with 25? I agree with 25. Rhiannon, positive or negative?
Positive.
Why?
I don't know. I'm just guessing.
Okay. Well, you got a 50-50 chance of getting it right. You guys know about 50-50-90? If I ask you a 50-50 chance and you guess, there's a 90% chance you'll get it wrong. You guys have experienced that, right? You should get it right every other time, and then you get it wrong and wrong and wrong and wrong. Guy, why positive? Why positive, guys? Rhiannon says positive. -5 times -5. It doesn't matter whether they're positives or negatives up here. +4 times +4, -5 times -5. This is always going to be plus. So what do I have here on the table? Obviously, didn't have enough tiles to put in 25 of them. Most of us don't have 25 unit tiles in our bins. I've got x squared minus 10x plus 25. That is in my square. I've still got a plus 16 hanging out over here, but I added 25. So the last question I have for you, what do I have to do to keep this equation in balance? Think about that one for just a second. What do I have to do so that I don't unbalance this equation now that I've added 25? Annie? I added 25. I've just unbalanced this equation by just adding something. What do I have to do to keep it in balance? Okay. Anyone want to volunteer on this one? Rhiannon? Subtract 25. Imagine that you've got a scale. Think of equations as a scale. If you add something, it makes one side of the scale heavier, doesn't it? So to keep the scale in balance, you either have to add the same thing to both sides, or you have to add it and then subtract it so that it stays in balance. By adding and subtracting this 25, we've kept the equation in balance. It's still equal to x squared minus 10x plus 16, which is what we started with. That makes sense? Okay. So now, what do we know about the stuff in pink? That's our square, isn't it? What's the area of that square? Looking at the picture up there, what is the area of that square? I'll give you another second to think about that one. How do I write the area of that square? Travis? Yeah, absolutely. The area of the square is x squared minus 10x plus 25. Just that part right there. There's the area of that square. But what's another way to write the area of that square, Travis?
X minus 5 squared.
That's it. X minus 5 squared. Minus 25 plus 16 combines to minus 9. That's the whole point of this. It's what Travis just said. We know that the area of this square is x squared minus 10x plus 25 because we can add up all the bits inside and find the area. But we also know that we can multiply length times width and write the area a different way. And this new way of writing the area is better for our purposes because now I know the vertex. Oh, Avery's not here. Eddie, where's the vertex? Oh, not quite. What comes first?
5.
And then?
9.
You sure?
No.
What aren't you sure about? Which part? Did I slide the parabola up 9 or did I slide the parabola down 9?
Down 9.
So what do I have to change in here? That's going to be negative? Or just this one? There we go. We completed the square. We know where the vertex is. Now, we'd already done this one. Remember, we found the intersects were 2 and 8. 2 plus 8 divided by 2. 10 divided by 2 was 5. We plugged 5 into here. 25 minus 50 plus 16 is negative 9. But this is much, much quicker and more efficient. Because we don't have to do quite as much work. Now, we're going to see one in just a second where we couldn't even, remember the one we couldn't even do yesterday because there were no x-intercepts? We're going to do that one in just a second. But right now, here's what I want you to do. Your turn. I'm going to just write it up in the corner here so that I'll leave these 2 examples on the board until we're done, until we're ready to do this one. Your turn. Here's what I want you to do. I want you to complete the square using y equals x squared plus 4x plus 9. You can use algebra tiles if you want. I'm fine with that. I would recommend that for this one you draw the picture in your notes just to get used to it a little bit. But if you're starting to you're like, oh my gosh, this is easy, you don't have to draw the picture. As long as you get it right every time. I don't care whether you draw a picture or not. All right? So, complete the square. Write it in vertex form, find the vertex. Go. 60. And how many x tiles do you have to use to build that square? There you go. The question for you. Is that the picture? Or did you just, you should not draw a picture? I don't know what the answer is, that's why. I now have to figure out the answer in my head really quick. Ah, good, I like it. You sure about that vertex? One little thing that you missed when you wrote the vertex. Yes. Also, why plus 13? Think about, I missed it until I just looked at his. Because I did the same thing in my head that you did. How did you get 13? Yeah, so remember, we add inside the square, so we subtract outside the square. That's that 13.
Plus -4 plus 9.
Negative 5. Yeah, no. It is definitely, it's 5, but not negative, right? So this is your square part. Agreed?
Yeah.
This is your balance, and so then we need to add those together. So here's what I would recommend before you write your oh, you wrote it up here.
Yeah.
But it's not gonna be plus 9, is it? Because you forgot about the -4 there. That make sense?
Yeah.
Cool. I like it. Make it, write it y equals, just for fun, since it's an equation,
Where, oh,
but write it as y equals, why -2 there, by the way?
Because if, when you square -2, it makes +4.
True, except that means that this is gonna be positive no matter what. But these are going to depend on our original equation. Our original equation had plus x's, whereas that one had minus x's, and then the previous one had plus x's. So we have to keep track of that every time. Yeah. Good. And what's -4 plus 9? Yeah, you're combining these two and then writing it down there as the, because that parentheses and this parentheses are the same square. What's left over is this stuff. So how much did you add?
Yeah, sounds like a phone that you know.
We added 4, right? So let's borrow this for a second. Think about this. If you get +9, you added 4, and this is your square, right? What do I need to do to balance out that? This is your square, and then that is your balance. That make sense? Cool.
Actually, I tried to.
Oh, that's x plus 2.
That's kind of hard.
Where's your vertex?
That's kind of hard. Okay, it's light.
Yeah, that's the one that switched. Good.
It's light, but you.
All right, yes.
How long you check this?
Oh. Yeah, no worries. Right, I thought I did. I love it, except, where's your vertex gonna be? All right, guys, nicely done. X squared plus 4x plus 4 minus 4 plus 9. We needed 4 to complete the square. There's my square, y equals x plus 2 squared plus 5. My vertex is at negative 2 comma 5. Very nicely done. Now, did this one factor? Could we have done this the old way?
No.
Two numbers that multiply to 9 but add up to 4? Wouldn't have factored. We couldn't do this the old way, but we could do it the new way. Guys, this is why we complete the square, because not only is this process quicker, but if we can't find the x-intercepts easily, we would have had to use quadratic formula, and then we would have got decimals, and then we would have had to add the decimals and divide by 2, and then it wouldn't have been super accurate. But at the end of the day, we were able to just easily complete the square. Should we go do another one? Oh, wait, what would this graph look like? Just out of curiosity. Negative 2. Oh, wow, look at that. It doesn't have x-intercepts. Negative 2 comma 5 is the vertex, and it goes up from there. So if we had tried to use quadratic formula, what would have happened? What happens when you use quadratic formula and there are no x-intercepts? How do you know that? Anyone remember? You get a negative underneath that square root in the quadratic formula. You guys remember that? We talked about this in algebra. Let's do a quick review of quadratic formula, because sometimes it comes in handy, and then we'll do another. Hey, you know what? I don't want to do a quick review of quadratic formula. Let's just do more of these. We'll do quadratic formula another time. We don't need it right now. How about that? No point in confusing the issue. All right. Let's look at the one that we talked about yesterday, which was x squared minus 4x minus 2. Before we start, g of x, does that make it different? Does that make this more complicated, more confusing? Why not, Alex?
That sounds brilliant.
Fair enough. Fair enough. Alex didn't even say anything. He just his head went like this. It like vibrated left and right. And I was like, I saw that. Guys, what does g of x mean? It means y equals. The only difference is that instead of y equals, we're going to call this function g, and I'm going to tell you that the input is the variable x. But really, it just means y equals. It's the same thing. Just another way to write it. More useful way to write it, because what if I gave you 10 different equations and they were all y equals, and I said, what's y? And you'd be like, I don't know, there's 10 of them. Which one am I supposed to pick? But if I gave you a of x, b of x, c of x, d of x, e of x, I could say, oh, which one is e? What's e of x? And you'd be like, oh yeah, that's that equation. So that's why we do that differently. So, can you complete the square on that one? Feel free to build it with algebra tiles if you want. Feel free to draw it if you want. Don't forget to write it as an equation every single time. Oh, that's okay. That's okay. I hadn't solved it yet, so I have to go through it in my head and to see if you had it right. There you go. You're welcome. It is. -4 minus 2
No.
equals.
I know it too, that was a mistake. It's,
Yeah, same thing. I can write it to them too. So I got a question for you. How many X tiles did you need to build that? 1, 2, 3, 4, 5, 6, 7, 8. But how many did you have? So really, there's your square. So how many squares do you have to add if you were to build this? What do you have to add to doing that? And so if you're adding for, let me borrow this for just a second. If you're adding 4 to make this a square, then you gotta subtract 4. And you say -2 sitting there. That make sense? So guys, I'm gonna make a recommendation for now. I'm gonna recommend that you do a couple extra steps. Some of you are sort of jumping straight to the answer, and not always getting it right. I'm gonna recommend the following steps. I'm gonna recommend that you write the square and that you write the balance each time. So we've got x squared minus 4x plus 4. There's my square, 2 by 2. Minus 4 minus 2. And I'm going to recommend for now that this be a part of your work. Oops, equals. That you not try to just do it in your head. You can do it in your head when you get really good at it, but to start out with, it's just not a good idea to do it in your head because you start to lose track, especially as they get a bit more complicated. And so then we get as our answer g of x equals x minus 2 squared minus 6, and our vertex is at 2, -6. And I think everybody now has that after a couple little corrections and false starts, but I'm going to strongly recommend that you show that +4 -4 each time. Okay. Questions so far? All right. So, what happens when we have no questions? We make it more complicated.
Oh, man.
Oh, man. Are you ready?
No.
Yeah, you are. You're going to be like, Mr. Emery, I don't really see how that was more complicated. What are you talking about? I'll say, oh, good. Then let's make it even more complicated. All right, here we go. P of x equals, that's not the complicated part, x squared plus 7x plus 10. So I want you, not to complete the square yet, I want you to build this with algebra tiles. Take about 30 seconds, grab 1x squared, grab 7x tiles. Of course, we're going to ignore the 10. We're going to make our square. I'm going to go ahead and write it, parentheses, x squared plus 7x, parentheses, plus 10. There's my square. Here's my balance. And build that one with algebra tiles. And then tell me what the problem is. How many people are on board with Alex's comment that he is not a square? Can you? Do we have a negative x up there in the equation? Okay, so proposal, we stick a negative x in there so that it will work. Is our equation in balance? It is? I just added something that wasn't there. I've added a negative x. It wasn't there, and I stuck a negative x in there. What do I need to do out here in order to compensate for that negative x? Which means that my equation would become x plus 3 squared plus x plus whatever number I did with my compensating. That would be what?
If you add a,
Minus 9, right?
can you add a positive x and then subtract 1?
Okay. So what if guys, well, first off, okay, so let's get to that in just a second. Is everybody comfortable that if I put in negative x, I have to add a plus 9, because then I'd have 6 of those, and 3 times 3 is 9. Yes?
Yeah.
And therefore, I have to put a plus x and a minus 9 out here. And I get x plus 3 squared plus x plus 1. Is that in vertex form? No, it is not. I need it to be x minus 8 squared plus k. I have no idea where the vertex is of this equation because it's not in vertex form. So let's try Alex's idea. I'm going to erase this. I'm going to take out that. I'm going to take out this. And I'm going to add an x, which gives me a total of 8. And I can make it a square. Yes? 4 by 4, which means that I need to fill it with what? How many? 4 by 4? 16, which means I need to balance it with what? And? Same problem, don't we?
Mm-hmm.
We seem to be at an impasse. Unless Travis has an idea.
You put 3 on one side and 4 on the other.
I'm going to draw that, Travis, because I feel like this is where we got stuck. I put 4 over here and 3 down here, and everybody agreed that's not a square. That's a rectangle. It's x plus 4 by x plus 3. So how do I make it a square? Oh, I just divide the 7 in half. I can't make it with algebra tiles, but I can draw it, can't I? What if I said, hey, I've got a really cool extra special set of algebra tiles, and my really cool extra special set of algebra tiles includes half tiles. So this is x plus 3.5 or 3.5, and this is x plus 3.5. Hey, look, it's a square. Happy days are here again. We made a square. Now, we can't use algebra tiles because we don't have half rectangles. But we can certainly draw them, and we can certainly visualize them and think about them. So what does our equation now look like? Well, P of x equals, oh, I'm going to just draw a line through that to remind us that no, can't do that. We've got x squared plus 7x plus something. Hang on a second, let me get my pink neon highlighter and highlight the square. And then we got minus something that we're going to put in there to compensate for whatever it is. And then we've got our plus 10. So the only question is, how much do we have to put in there to make that a square? And how much do we have to subtract to balance it out? First off, the green box. How big is the green box? Sides. You're jumping ahead, but yes. How big are the sides of the green box? 3.5 by 3.5. So we have to multiply 3.5 times 3.5. And it turns out that that's actually really easy, because instead of multiplying 3.5 by 3.5, I just know that it's 35 times 35. And I just remember back to my 35 times tables that that's 1,225. And so you all knew that one. Maybe you had to think about it for a second. I haven't done 35 times tables in a year or two. Never?
No.
What, did you guys go to Meridian? I mean, if you didn't do 35 times tables, I would have assumed you went to like Ferndale or Nooksack or something.
I did online.
Oh, you did online? That's why you didn't do 35 times tables. Because here at Meridian, we went all the way up to 75 times tables, right? Everybody's going, what are you talking about? No, we didn't do 35 times tables. Don't feel bad about your online schooling. You got a good education anyway. Here's why I know that. Because over the years, I've tried to memorize as many perfect squares as possible because I do math all the time. So 15 squared, 225. 14 squared, 189. I don't remember all of them, but I remember some of them. 20 squared, obviously 400. That's an easy one. 25 squared, 625. I've got a lot of them sort of floating around in the back of my head. And here's the nice thing about remembering these. First off, I didn't have to waste time digging out my calculator, and this is useful for multiplying all sorts of numbers. If 35 times 35 is 1225, if I put a decimal here and a decimal here, there's two decimals, which means that I'm 12.25. 12 and a quarter. Now, can you just grab a calculator? Sure. But if you don't have to grab a calculator, it's sort of nice to be able to just write down the answer. Plus 12.25. What do I need to do to balance it out? Subtract 12.25. P of x equals, all right. What's the area of my square? Volunteer. What is the area of this square?
Plus 30 or 3.5.
length times height. And what do these combine to?
-2.25.
And where's my vertex?
3.5, -2.25.
We agree?
No, that's just my
-3.5, because it's always opposite. I know. So easy to forget, huh? Hey, look at that. I could graph that really easy on a piece of graph paper. I mean, I have to be careful because I'm starting at 1/2 and 1/4. But if I just went to graph that, I would say 1, 2, 3, 4. There's -4, there's -3. 1, 2, 3. There's -1, -2, -3. -3.5 is right here. -2 1/4 is right there. And because I have graph paper, it's actually going to be more accurate than just doing it on a whiteboard. There's my vertex. Now, quick graph. Where are the next 2 points? Don't give me numbers on the graph. Tell me how far. Anyone? Quick graph. Start at the vertex and do what?
Over 1, up 1.
Over 1, up 1. I don't care what the numbers are on the graph. All I got to do is go over 1, up 1, right? Well, if I go over 1, I'm at 2.5. And if I go up 1, I'm at -1 1/4. And if I go over 1, I'm at 4.5. And I go up 1, I'm at -1 1/4. Boom. Quick graph. Where's the next set?
Over 1 up 2.
No, because it's a parabola.
over 2 up 4.
Over 2 up 4. Remember, 1 squared is 1, 2 squared is 4. Yup, is right. So I go over another 1/2, and I'm at 1.5, and I go up 4, and there's 1 1/4, 1/4, 3/4, 1 1/4. Nope, 1 3/4. It's a little more complicated, but I'm just counting spaces. This would be way easier if I had a grid, because I would just count 4 spaces, and it doesn't matter. I don't have to like think in my head where am I supposed to be. I just count 4 spaces. Here, we should probably put some spaces on here. What's +1 and +2? Who writes +1 on a graph? Nobody. And then, of course, here I am at -5.5. And I've gone up the same amount, which was 4 grid spaces. And hey, look. Oh my gosh. That's like the best parabola ever.
Bless you. Bless you.
Guys, this is the beauty of quick graph. 1, 1, 2, 4, boom. I graphed a parabola, and I knew where the vertex was because I completed the square. And it doesn't matter how awkwardly complicated the vertex is. Once I had the vertex on there, I went 1, 1, 2, 4, boom. I got a graph of a parabola, and it's beautiful. Much, much easier than looking in your calculator and plotting a whole bunch of weird decimals, because that's what they all would be. And the vertex wouldn't even be in your calculator, would it? Because it's at -3.5, and your calculator would have given you -3, and then it would have given you -4. And so your calculator would have given you this point and this point instead of the vertex. We cool with that? I know what you're thinking. How does Mr. Harmony get so excited about graphing parabolas? This is fun. I really do. I think this is fun. I know you guys probably think I'm crazy, but I think it's really fun to be able to take some weird equation that I don't know anything about. I mean, I know the y-intercept because, you know, x is 0, y is 10. But how does that help me? That's up here somewhere. And to be able to just do this math every single time the exact same way and just fiddle with the numbers, and then boom, I've got this beautiful graph. By the way, I am as unartistic as it comes. I could not draw a nice picture for Mr. Holtz and pass his class to save my life. But I can do this stuff, and it's so much fun. All right. Guys ready for do one on your own? Yeah, you are. Yeah, you are. Boom. Here we go. Oh no, this is your turn, not our turn. Here we go. Y equals, I'm making this a y equals 1. X squared plus 9x plus 12. Yeah, you're right, it did, didn't it? Let's make it plus 20.
Yeah. I'm looking at I'm not sure yet.
Yeah, me neither. But if you had a calculator, I think you'd know. What are the side lengths of that square? That way, that.
4.5 times 4.5.
There you go. Don't do it long enough off to the side.
Why not? This takes too long. It's a waste of time.
You have a calculator somewhere?
No.
How about on there?
On my calculator, I was even marking.
Oh. It's Chromebook?
Can I just use my phone for this?
No, Chromebook though. You need a Chromebook.
You serious?
You could, but you're not gonna, not in my classroom.
You probably won't get it.
I'm just so anti having phones around when we're trying to concentrate. It destroys concentration. That is a scientific fact. So how big is your square? There you go. Yeah, but you're not squaring that, right? You're splitting it in half to make it square. So you got 4.5 on each side. I assume that's how you got this. And so now your square is x plus 4.5 minus 4.5. Cool. Now, yeah, no, that works. That's perfect. I like it. So, is that really plus 9? What are the dimensions of that square? Uh-oh. So this isn't squared, right? Remember, these are the lengths.
Oh,
So your square isn't x squared plus 4.5x all squared, it's x plus 4.5 squared.
yeah.
Cool?
Yep.
All right, guys, very quickly, because we're about out of time on this. Tell me about my square, Luke Van Rye. X squared plus 9x. What do I have to put in here to make that a square?
X squared plus 9x plus 4.5.
Ooh, my.
Oh, no, 20.25.
Yeah, there you go. My square is x plus 4.5.
Yeah.
And you know, blah, blah, blah. We're not going to drive. What do I have to subtract, Luke?
You have to subtract the 20. Oh, you have to subtract 20.25.
Good. So, next step. Tyler. Wait, what?
Oh, you got that now. Okay, no. You move seats. Mess me all up.
Tyler, how big is this square? What are the dimensions of this square?
X plus 4.5 squared.
There you go. It has an area of x plus 4.5 squared.
Good morning, Meridian. Please stand for the Pledge of
We'll
Allegiance.
finish this in just a second.
I
Pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. You may be seated.
We're gonna
Now
do
time
that.
for the joke. Two windmills are standing in a wind farm. One asks, "What's your favorite kind of music?" The other says, "I'm a big metal fan." Have a good day.
Okay, it took me a second. Yeah, now I get it. What do these combine to? Negative 20.25 plus 20?
Negative 0.25.
Guys, you see how this would have been pretty complicated if we'd done it the old way? This factors to x plus 4, x plus 5. 4 times 5 is 20, 4 plus 5 is 9. The average of negative 4 and negative 5 is negative 4.5. Negative 4.5 squared plus 9 times negative 4.5 plus 20 is apparently negative 0.25 or negative 1/4. So again, much less complicated to complete the square and then just look at this and say, aha, the vertex is at negative 4.5 comma negative 0.25. All right? Okay, so here's what I got, because now we got T3. I'm going to give you a little bit of a break. I got snacks. When I say I got snacks, I mean the school provided snacks. What do we got today? I hope you guys like blueberries. Because the choice is blueberry, medium muffin loaf.